monitoring air pollution effects and so forth. He's now back at UBC working on a master's degree under the direction of Stu Steen, who we're pleased to see here today. I'm sure he'll have some good questions. And yes, telling us about his experience in North.
Talk a little bit about my experiences working for the Ministry of Environment for the last 10 years. Most of that has been as the air quality meteorologist for Skeena Region and Smithers. Some I worked compiling a micro emission inventory, and near the end I was focused entirely on impact assessment with LNG. Okay, so Smithers, where's that, right? Well, if you follow these simple directions, you can get there too. If you were to leave right now, you'd get there in about 13 hours. If you had a U-Haul with all your family's possessions, it would take about 16, which is what it took me to drive down here. Okay, and why? I just want to thank Mike for giving me this slide. Essentially, what I take away from this slide, which I saw Michael Brow present a few months ago in the spring, was that air pollution is a serious issue. People die in Canada from air pollution exposure. 7,200 deaths per year from PM 2.5 specifically. And so you don't need to go away to some place that's a lot more polluted and come back and say, hey, we don't have an issue. How many deaths per year is acceptable? Certainly to me, 7,200 in Canada seems like a lot. So what am I going to talk about? Well, I thought I would start by just giving a brief outline of the Environmental Protection Division, which is a division of the Ministry of Environment that I work in, and what its goals are. The Environmental Management Act, which is an important piece of legislation that deals with the discharge of contaminants to the environment. And then some issues with particulate monitoring. I call it fun. That's facetious for hard at times and frustrating. And then I thought I'd do some journal entries. I had to cut it down from so many that I had so that I could fit it in 45 minutes. And Kitimat is the thing that Sarah had asked me to speak about, so that's kind of the longest journal entry. And then some summaries, and then there's time for questions. Okay, so the Environmental Protection Division, there's many divisions within the Ministry of Environment, Parks, Climate Action Secretariat, and the Environmental Protection Division is the division that tries to enhance the quality of BC's water, land, and air. And what else do we do? Improve air quality, reduce greenhouse gas emissions, improve surface and groundwater quality, reduce and remove toxins that contaminate the land, and enhance environmental stewardship. So we want to see pictures like this, which I took a little while ago, and not pictures like that, which was taken September 13th of this year. So that's those are emissions from the burning of forestry residue, which I'll talk about in a sec. Just wanted to go to the next slide. Okay. Within the Environmental Protection Division, there's branches, and the biggest branch is the Regional Operations Branch, and that's the branch that I'm in. So for those of you who have a lot of colleagues in Victoria, maybe they're in a different branch. The Regional Operation Branch does the things that are on the left of this slide. Big things in administering the authorization process for discharges to the environment. That talks about why an industrial facility would need a permit, for example. Of course, this is Skeena Region, so Skeena Region is about a quarter of BC, pretty big. And if you haven't heard of a lot of those communities there, it's true we have low population, but where we have a small population and communities, we have big environmental assessment projects. So this, for example, is, we spend a lot of our time dealing with environmental assessments. This is the Kerr-Sulphurets-Mitchell environmental assessment application. That's one. So not all of that has to do with air quality, thankfully. But yeah, they can be pretty big. A lot of staff time is dealt with environmental assessment applications, specifically relating to future permitting, of which air quality is a small part. So the Environmental Management Act. This is the piece of legislation in BC that is all about discharging waste into the environment. And the term waste is an important term. It's defined in the Act, and in the waste discharge regulation. If you don't get burdened down with all the details, but since I was told I should that people might like it, so here it is. So basically what it says is in order to discharge waste, so waste could be an effluent into water or contaminant into the air, you need to do so under the terms and conditions of a permit approval, which is like a short-term permit, an order, a regulation, or a waste management plan. And that's very important. Of course, so not everything requires that. For example, you don't need a permit to discharge emissions from your car. Well, that's because there's a few exceptions, right? Motor vehicle emissions, if applicable, complying with the Motor Vehicle Control Act are exempt, so you don't need a permit or an authorization of some kind to drive your car. Similar, if you've got a restaurant and your restaurant is burning all the food and you have high emissions and venting outside, you don't need a permit for that either. One of the more complicated exempted activities are the emissions from wood stoves. The government regulates the sale of wood stoves, but not the use of wood stoves. So we'll talk about that in a little bit. But the one important detail is no exempted activity or is exempted from causing pollution. Pollution has a specific definition in the Act. So while most people may have their own definitions of what pollution is, the Ministry of Environment under the Environmental Management Act has a specific definition, which means the presence in the environment of substances or contaminants that substantially alter or impair the usefulness of the environment. So that's an important thing to keep in mind. Because you might see something and say, that's pollution. Well, it may be to you, but it may not be according to the Environmental Management Act. Okay, so transition into the important pollutants that we see in Northwest BC. The first one and the most important, I think, for me is particulate matter, right? I was shopping around online for things associated with particulate matter. I came across a website called Spare the Air, and they had an elemental symbol for PM, which I thought was pretty cute. It's not an element, of course. It's a complex mixture of elements of which all of these different compounds have varying toxicities, and so it's not just one thing, but I thought it was really an interesting thing to think about. Bad for you when you inhale them. Like, this is being the School of Population and Public Health. You guys can probably teach me about all of that, so I left it as just putting it that way, with noting that it's an understatement, and hard to measure too. Some people may not realize that when you're dealing with particulate matter data, you really have to know where your data is coming from, because that will have a large impact or effect on the outcome of what you're looking into. The way we have typically seen the gold standard, that's a term that I've heard used a lot, is this gravimetric method, where you take a filter. The before is the white one, and the after, again, is the dark one. That's not always what they look like, but after is usually darker. But and you pass a known volume of air through the filter. You have its before weight. You know its after, where you measure its mass. The after and the difference in the mass, along with the flow, gives you a concentration. Of course, there's some drawbacks in that. Let's say you may sample over a 24-hour period. Right, so you might want to know what the concentrations below in an hourly or even on a minute-by-minute basis are. Also, you'd have to send that filter sample away to a lab, and it can take up to weeks to get the data back. So what we've done is, or we, by say we, I mean companies that make particulate instruments, they've kind of calibrated their instruments to emulate the values you get from a 24-hour basis from this gold standard. And it's actually quite difficult to do. So what you're seeing here on this graph are various measures of the same thing. So you have a blue line, which is a newer instrument that we've installed in Smithers in 2010. A black line, which is the older, more traditional instrument that we've had running there since 2004. And the reference method, which is that gravimetric method, the gold star, and that's the red dots. And the blue dots and the black dots are just the 24-hour values on those days that the reference machine was operating. And what you can see is there's quite a spread. particularly in the cold times, cold season, especially between the black values. That machine, by the way, is called a TOM. And I won't get into machine specifics right now, because that would take a long time. But and the blue one is called a sharp. And so yeah, the black line tends to be a lot less than the blue line, which is not necessarily a good thing. That's most PM 2.5 instruments in BC are still TOMs, but we're transitioning to these other ones slowly. Okay, so how different are they? Well, what you can see from a comparison, and it's seasonal because of the temperature change between outside and the instruments inside. So in the wintertime, there's a lot more under-measuring by a machine like the TOM. On average, is only about 64% of what the reference method measures, right? With the sharp, they do quite a bit better, and that's about the same, plus or minus some error. And you know, there's a really big thing because a lot of our data historically has been with TOMs. So when we have all of our objectives and we issue advisories based on data that's currently being generated by these numbers that we know are under measuring. So just a word to always know where your data is coming from, and always keep that in mind when you're doing your work. I know that I keep that in mind when I do mine. And we were supposed to transition last year. Of course, we didn't get there in time. Probably by the end of this year, we'll have most of the stations in BC, at least in Skeena region, will have at least the newer instruments running in the background. In Smithers, we've had the sharp running since summer of 2010, and every other station except Terrace and our stations in Kitimat have newer instruments, they're sharps. And yeah, this is a common issue across Canada. A lot of communities, provinces, jurisdictions are transitioning right now. Okay, so that's a little bit about PM. The next few slides are all about PM2, and then in Kitimat it's not as much anymore. But so this is my first journal entry, the unfortunate story of wood residue. And I found a really funny picture online that I wasn't sure if I could use because I couldn't get in touch with the person who posted there. So I just took a picture of my brother and sister-in-law's houses. They were building it. Shows that we use a lot of wood. Wood is important in our society it's the #1 industry in our economy provincially, and generally we use a lot of it, especially when we're doing things like building homes. The unfortunate part, from my perspective, is that it creates residual, which is sometimes known as waste, sometimes known as residue. It just depends what lens you're looking at things with, and the waste needs to be dealt with in some way. So this is how a lot of forest companies deal with the residual. The Ministry of Forest Lands and Natural Resource Operations requires that forest companies abate the fire hazard left behind by all these piles of slash. That's the part of trees that aren't brought to a sawmill. And the cheapest way for them to do it is to just light it on fire and burn it in a time when it's safe, like the fall, which is, you saw that picture from September a couple weeks ago in Smithers. So this is one I don't often get to fly, so I use this picture a lot because I took it on a day that was really good. The picture on the bottom right is burning of waste associated with the creation of the Northwest Transmission Line. So, but the big one is from the lakes area, so I thought it was nice to include it. Then the waste stream doesn't stop there. Once trees get to a sawmill and they're turned into dimensional lumber, there's more residual material, and it also needs to be dealt with. It comes from the milling and planing of wood, of trees into dimensional lumber, sawdust, shavings, etc. And this is the way it used to happen. It doesn't really happen very much more like this because most beehive burners aren't around, but you can see from this emissions a nice stable day in the wintertime in the morning, and the plume hugs one constant layer. It just gets stuck up in in that layer where it comes from. So that used to be the way that a lot of forest companies dealt with their waste at a sawmill. They don't do that much anymore. There's what they've learned was that there's better ways of doing it. You can use this material to heat your buildings, to fire your kilns and dry your wood, right? Or you can use this residual material to make pellets. So there's a lot of nice things that we can do with this stuff that is not as emitting as a beehive burner was. Unfortunately, it still doesn't always work that way because the creation of wood pellets can also be a high emitting activity, especially when you're drying the wood at a high temperature. Driving off a lot of the VOCs, and you also have to burn wood to do the wood drying, so there is some added combustion. And this is a picture from a couple years ago, and it shows cloudy skies but hazy in the valley bottom, right? That's not cloud. That is the emissions from a pellet plant where their pollution control works weren't working quite well. So, so this is a bit of an, you may argue, an unfair picture, but I took it. You can see from the three stacks, which are their main exit stacks, they had to bypass because their pollution control works weren't working, so they were bypassing a lot, creating a lot of that haze you saw in that last picture. As a result of this, we start to get a lot of complaints. We got a lot more complaints from the creation of this pellet plant, supposed to be a lower emitting thing than we did when we had a beehive burner. And this is a plant that's 20 kilometers out of Burns Lake, and the closest residents are 8 kilometers away, and the beehive burner is only 4 kilometers away. So we seem to think that something wasn't going on. So we really had to look into it. An important thing to note is once an industrial facility like this gets going, it's hard to just turn it off. All the waste streams get diverted from various places, and you can't just shut a pellet plant down. It's quite complicated. So what we did was we got a portable particulate matter monitor from a colleague of mine in Nanaimo. We set it up at a house where at the complainant's house, 8 kilometers away. And what we seem to notice, what you can see is these black lines are the hourly values, and the red line, if you can see it, is a rolling 24-hour average concentration. What we noticed was we were never actually exceeding any provincial objectives, which I show on the next slide. Maybe I should have put on the last one, but the provincial objective is 25 over a 24-hour period. So we got about halfway there, and most of the time, except for when we were measuring forest fire smoke from Siberia and some locally. But what we did really notice was that we were getting 3 and 4 hour high peak values in the morning time when the wind was coming from the direction of the pellet plant to the complainant's house, essentially filling a shallow valley up with smoke. And then as the day would progress, the mixing would increase, and the mixed layer would increase, and slowly it would move higher than the height of the nearby hills, and the plume would disperse rapidly after that. So it's essentially like being fumigated for 3 hours, 4 hours in the morning time. And the complainant didn't have access to this data. They kept a diary of the worst days, which matched exactly with all of the circles that you see there, the dates of the circles. So we really could pinpoint the emissions, and to get hourly concentrations in the above 60 from a source 8 kilometers away seems pretty high, actually. We also noticed that there were some spikes we couldn't explain until we found out that there was the neighbor was having campfires. So it really does show that you don't have to have a giant industrial emitter to be getting a lot of smoke in your face. So you can also have just a neighbor with a smaller campfire. So we had to put that into perspective for the complainant. But it really did broaden my understanding of, it verified all the complaints that we'd been getting, and certainly the newspapers were on it like so they were all over it, and it's important. I mean, we didn't really expect this unintended consequence of, we're trying to divert waste streams from being burned. This pellet plant also was diverting forestry residue waste, right? So not only were they taking what was used to come at sawmills, they were also taking wood out of the bush and making pellets with it. And that that seemed like a big win for everyone. If you look at our ambient air quality objectives for particulate matter, you won't find a 3-hour objective. The shortest objective we have is a 24-hour objective. I remember sending Mike an email saying, what are the studies at for fumigation, right? For short-term exposure to high particulate concentrations, and there just aren't. We had the consultant, or we had that pellet plant actually hire consultants to redo their dispersion modeling, to go do a jurisdictional review of short-term objectives. Does any jurisdiction anywhere have shorter than a 24-hour particulate matter objective? We had them buy an EBAM and put it there permanently, and the EBAM compares really well to the reference method. I didn't have time to show that graph, but so we know it's measuring fairly well. And but that's one thing that I really took away was can you use the Environmental Management Act to call what they're experiencing pollution or not? And I don't know what the answer is, because they're not exceeding our objectives, and our objectives are based on health science. And so, yeah, it's just a really challenging case. The note to myself that I think I came away with was that there can be unintended consequences anytime you try to deal with the waste. So maybe the best thing is to just not create it in the first place. But the fact that not only were we taking residuals from other sawmills, but we were taking slash that get burned in the bush generally when the weather and dispersions were good, sticking it in the bottom of a valley and allowing it to be emitted 24 hours a day, 7 days a week didn't seem like a win-win for everyone. And from my perspective, if we knew more about short-term exposure, maybe we do, and the answer is that it's not a problem. But I don't know if we do, and I don't know if that's the answer. So that seems to be one area of study that you guys can all take on that will help me with my job later on when I go back. Okay, the next one, Houston. Here's a community with 2 emission sources, and the 2 main ones, one is some industrial facilities, and the other one are wood stoves. This is quite common in northern and central BC. We have air quality issues in the wintertime. So we had to tackle this in a way that made sense by tackling everything at the same time, and we did. And we spent invested a lot of time in trying to reduce emissions from wood stoves. We ran the provincial pilot wood stove exchange program in the Bulkley Valley Lakes District Airshed. That was then rolled out to other parts of BC. And yeah, I said before, the Ministry of Environment regulates the sale of wood stoves, and local municipalities can regulate the use of wood stoves. For example, in Houston, we worked with them. We created the first ever bylaw of mandatory removal of old uncertified stoves in Canada. And so that's good. You can't use wood stoves when there's an air quality advisory, which is also good, unless the caveat is if you have no other heat source in your house, and you still can. And I think we did a pretty good job. What you can see here, if you can see it, are exchanges by year. And especially considering that our air quality monitoring location is kind of in the center of this area. And this is a trailer court. We changed out quite a few stoves. So yeah, we took out a lot of emissions out of the air from that. The other thing that happened, of course, you can argue, was this really a lot of money well spent, considering we spent so long to only change out 100 wood stoves. And other communities have this very same issue. I spoke with someone from the city of Montreal. They have 85,000 wood stoves in the city, and they're also trying to deal with wood stove emissions. So it's not just a small town issue. The other thing we did was, thanks to the throne speech a few years ago that said we're going to get rid of all beehive burners, we got rid of the beehive burners in Houston. I say we, it wasn't me per se. The forest companies developed things to do with their residual waste. And so there's about 1,000 tons less per year now than there was emitted in 2005. So 1,000 tons of PM seems like a lot to me. So, but yeah, there's still an issue. They have a pellet plant too. it's the drying of wood that creates those VOCs that are so blue that you see there. In terms of improvements made, I did this for another report and I just kind of took it. It shows the annual rolling average of fine particles. I like that because you can see the small fluctuations from within a year. You can see really well the effect of a forest fire, that where the circles are on the right-hand side of a graph. So a forest fire really affects your annual average. And if that forest fire went there, it would look like a nice, even better decrease. I did some simple calculations. The mean before those beehive burners were taken down, before the wood stove exchange, is about a microgram per cubic meter higher than the mean after and the annual mean after. And while that's, I guess that's a modest improvement, you could say. It seemed to be a lot of effort to get that 1 microgram. If you don't like those stats, you can use a conclusion that Carl Schwartz, who's a statistics professor at Simon Fraser University, said, which is when I prepared a stats refresher course with a colleague of mine. We gave Carl Houston's data so that he could use that to help us do examples of linear regression with sine cosine function built into account for seasonality. So we have made improvements, I'd say, to a point. We spent a lot of money, a lot of time, a lot of weekend hours and regular hours on community-based social marketing and outreach and working with municipalities to get that 1 microgram. But the issue is that these are all measured with with the TOM machine, right? So if you look at, if you take the relationship between the TOM and the Sharp, which is the newer one, and you account for the seasonal difference, and you build in a model to look backwards at what our concentrations would have been had we been measuring with Sharps the whole time, you'd see that our annual means exceed the provincial air quality objective of 8. And our 98th percentile daily value, all of those backcasted concentrations exceed the 25, which is the provincial objective for the 98th percentile. So we still have a far way to go, right? And that at times seems quite sad. But it's also, that's where the opportunity comes from. So for myself, as I reflect back on that, notes to self, improvements can be made by a long concerted effort. Has it really been worthwhile? I'd say yes. I spent so long doing it that how could I say no? And I'll be back there and again in a couple of years, so have to keep optimistic. But this is the big thing. Like this is, and that is the same for all communities. When we consider that we're going to be transitioning to newer instruments, it's going to make it seem like the air quality is way worse. It's the same, but we're using different instruments to take our measurements, right? And that will keep me employed. And then, yeah, if you want to get better, how do you get better? You have to work more, and that means that everybody's got to chip in. When I say everybody, air quality improvement's generally not a individual thing. It's hard for one group or one company. Usually we're dealing with the collective through an airshed planning process where everybody actually has to show up and have something to bring to the table. So if you show up and have nothing to bring, then you're not going to get anywhere, which has happened before. Okay, the last case, Kitimat. I've got more cases. We can talk after about the other ones. Development. Here we go again. Maybe I had to put those last ones in because Kitimat has been in and out of development, in and out of the news. It's in right now, in a big way. Yeah, I took this, or I didn't take this picture. I was in a helicopter with someone else who took this picture when we were in May. We were trying to fly the path of the plume and look at LNG future sites, and so it was really interesting to do that. If you looked at concentrations of pollutants in Kitimat, which I'll show you later, you'd say, what's the big deal here? Where the community lives, which is kind of in the middle of this picture on the hills here, is thankfully removed from where most of the industrial emissions are here, which is on the west side of the valley. The wind really hugs the west, and that's an important thing. However, there's also the environment around, and Kitimat has had no, well, it's had a few large environmental issues in the past. In the 60s, I think Dr. Leonard Weinstein, who's a plant pathologist and not related to me, documented the defoliation of the forest as an environmental calamity. And that's documented in his book, Fluorides in the Environment. It comes from fluoride emissions from the smelting process. Fluoride is great for your teeth, bad for plants, bad for your bones, displaces calcium, and can cause skeletal fluorosis in really high doses, I guess. But there's also been taint associated with pulp mill effluent that's changed the taste of oolakan. And we also know that there are some lakes on the west side of the valley that are very susceptible to the input of acidic compounds. I'll talk about that in a sec. Kitimat doesn't look like this anymore, but at times it used to. Air quality issues in Kitimat were different than air quality issues in a lot of other parts of northern BC that have wintertime, high pressure system, no movement. Instead, in Kitimat, from my experience, we have issues in the spring, summer, and fall. In the wintertime, when there's a high pressure system, it tends to create this Arctic outflow with really strong winds. So we don't measure a lot of high pollution, air quality contaminants in Kitimat in the wintertime. Instead, sometimes if you get a rigid high pressure building in the spring, summer, or fall, you can get pictures that look like this. It doesn't really look like this anymore, but you can still see that you can still see the blue haze of industrial emissions there, hugging the far side of the valley. This was passed to me by someone who happened to be in a boat that day. And the journal entry that I want to talk about for this case is the use of quantitative health impact assessment and how we used it within, it was used by someone else in a permit application that we reviewed and definitely helped move the application along. So there's an aluminum smelter in Kitimat, the only industry that's currently there. There's a lot planned. And they received, the company that owns it is called Rio Tinto Alcan. They received a notice to proceed on the construction of a new smelter in 2011. That really started moving the permit application process along because they needed a new permit because their sulfur dioxide emissions are projected to go up by quite a bit. Even with a new control technology and improved smelter efficiency with a new smelter, the result of making more aluminum and the increase in sulfur content in petroleum coke, which is one of the ingredients in the catalytic process that takes alumina and makes aluminum, means that there's projected higher sulfur dioxide emissions. And at first they did dispersion modeling, which I get to show you on the next slide. The results were really high, higher than our provincial objectives, the highest I've ever seen. And how much of that was the fact that the model was just making artifacts, or how much was real, not too sure, but we try to keep the artifacts down and the real up. So these, I'm sorry if this is a challenge to see, but essentially these are predicted 1 hour maximum concentrations in micrograms per cubic meter. And the important thing to notice is that the maximum offsite one is like 2,630. And so that's the maximum projected concentration for that year. These concentration isopleths are the maximum projected for that one little pixel, for a pixel in this picture per year. Keep in mind, the maximums don't all have to happen at the same time. It's just the maximum concentration at that spot for the year. It makes nice, pretty graphs for people like me to interpret, and these are important graphs in permit applications from the output of dispersion models. The maximum residential predicted concentration was 1,500, and our ambient objective is 450. So you can see that the predicted concentrations were a lot higher than our provincial air quality objectives. And what we ended up saying was this, you guys have to do a health study. Like, is this real? Is this really going to happen? And what does it mean for the people living there? And so they did. And the increase in SO2 emissions go from 27 to 42 tons, so that's quite a bit. So they did a quantitative risk assessment. And again, this is something that you guys are probably way more familiar with using than me, but I'm going to try to say what I think it's all about, and then later on you can correct me and let me know if I got it right or wrong. The first part is hazard identification. So what are we dealing with, and what are the effects? Then you do an exposure assessment, which is, okay, how much are we breathing? The concentration response is, okay, given how much we're exposed to, how much harm do we expect from that? And then the last step, risk characterization, was, okay, how do you put all that together and get something meaningful? So this brings us to important pollutant number 2, which is sulfur dioxide, formed from the combustion or oxidation of sulfur-containing substances, known to exacerbate symptoms in those with asthma or COPD, respiratory morbidity. It doesn't create new asthmatics, but exacerbates symptoms in those who are already asthmatics or have COPD. Sulfur is an essential nutrient for plant, but in high doses it's not good. It's also precursor to acid rain, precursor to particulate matter, and we tend to measure it in parts per billion, and then convert it to micrograms per cubic meter with standard temperature and pressure. Okay, so I said I'd show you what Kitimat's like. You can see for yourself. Don't worry about the exact numbers, but essentially, I mean, we're coming from a pretty good place. If you look at the red square in the middle that says River Lodge, and then you follow that arrow back to where the green line is along the y-axis of the bar graph, you'll see that it's pretty low when you compare it to other communities in BC, and this is considering that there's already a giant industrial facility emitting SO2 there. So, and that was in 2011. Kitimat Village, which is across the Douglas Channel on the east, is pretty much near the bottom of the graph. The only places where we measure really high concentrations of SO2 right now in Kitimat are fence line stations, which are called KMP, which is this big high one here, and Kitimat Hall Road. So we're starting in a good spot. How much do we breathe? Okay, I didn't do this work. This was done by Risk Sciences International on behalf of Rio Tinto Alcan for a permit application. So if I get some of it, if I can't explain some of it, I'll just ask me later and I'll try to explain it again. But essentially what they did was they divided Kitimat up into four main areas where people live and or work. And that's A, B, C, and D, Upper Kitimat, etc. You can read that. And then they had to make some assumptions in their model so that they could feed it into assumptions with a baseline so they could feed into the model. So we start with a population of 10,000. We estimate that there's 8% have asthma, 4% have COPD. You put that together for 12%. Then you estimate that out of that 12, there's 75 active, exercising 200 days per year. Seems like a lot, but we'll just say that's how it is. That equals a total of 180,000 exercise events. 50 outdoors, or 50% outdoors, 50% indoors. And it will distribute those across those four areas based on, loosely on population. We can do some sensitivity tests later to move that around and see what happens. And their events are distributed throughout the daytime hours, not at night. People aren't exercising at night, but they're distributed randomly through space. What we have here is a probability of response based on concentration. So if the concentration is a certain amount, within these bins here, you get a probability of having a respiratory response. This comes from the EPA, from their the promulgation of their recent sulfur dioxide standard. And you also have the bins of all those pixels within those areas A, B, C, D. This is a histogram of all the concentration distributions. So I'm going to spare you all the details of how everything happened, but when you distribute exercise events within those bins, you have essentially you have a probability of response that's really low, even with a low concentration, and you have a higher probability of response with a higher concentration, of course, there's fewer of those. So when you add up all of the responses, you end up with more responses coming from those events that take place in these low concentration histograms, just because there's so many more of those hours. And how many responses? Well, this is the estimated number of responses annually based on area. What it all amounted to when they were finished was that out of 180,000 exercise events across 4 locations, that translated to approximately 200 restricted airway symptom events. So, and the base case was 60,000, which they estimated from maybe 1 asthma attack per person per week, right? So even though you start with these giant concentrations that are predicted through a model, when you do a quantitative health impact assessment, you end up with a lower number, or not a lower, a number of respiratory events, and it's the statutory decision maker who gets to decide on, really, is that okay? So he still has to decide on a number. Like, it's just not a concentration anymore on a map, it's a number of events per year. And the consultant who was doing the work, they put it in this, the yellow area of moderate outcome, acceptable but in need of closer scrutiny. So that's what happened in the Kitimat role. That's what Sarah asked me to talk about, and that was a big thing that we spent a lot of time on. We engaged Northern Health. It wasn't all just the work of the Ministry of Environment saying, hey, that looks good. But we went and engaged a lot of people to make sure that, yeah, this actually was done properly. And the words we got back from others who know a lot more about quantitative risk assessment were that it was done okay. And then the decision maker ended up making a decision, amended a permit based on this and other information that he took into account. Though I should say that permit is currently the subject of an appeal. So maybe the permit decision will be overturned and they won't be allowed to emit 42 tons a day. And we'll find out later in January. So what I've taken away from that is I think there is a role for quantitative health assessment. That was a really important thing in Kitimat when we were looking at a really complicated permit application that had a really high economic stake. And at the end, I didn't talk about it, but you also have to follow something like this up with monitoring so that you know that the outcome is as predicted or better and not as predicted or worse. I'm almost out of time. I'll just briefly touch on liquefied natural gas, because how could I, being in Kitimat, it's such an important topic. And I don't know if you heard in the news, the government, the Ministry of Environment and Ministry of Natural Gas just announced $650,000 towards doing Airshed Studies in Kitimat with scenarios. Everybody's quite interested in the capacity of the Kitimat Airshed. LNG emits, there's some predicted SO2 emissions, but now we're dealing with a new pollutant, oxides of nitrogen. It's also a precursor to acid rain, and it also forms PM downwind, and it also is bad for you when you breathe it. Again, understatement. I'll let you guys tell me exactly how bad. And when I was still working there, the concerns that we were raising were, okay, how are all these pollutants going to interact with each other, not just individually on their own, but do they have a synergistic effect? Do they have an additive or competitive health effect? This is a really important part. And the Air Quality Health Index is often used to kind of merge the effects of many pollutants to give you a number between 1 and 10 and sometimes higher than 10. But SO2 is not one of the ingredients of the AQHI. And when we were shopping this idea around, people were saying, well, what about long-term effects? AQHI is nice when you're trying to figure out if you should go for a jog or exercise, but what about chronic exposure to a combination of all these pollutants? So this is a big study, and also the airshed capacity from an acidification point is really big, and eutrophication, which is depletion of oxygen in lakes and water bodies, etc. So you can imagine that various studies are underway as part of the environmental assessment process. The end, okay, what did I take away? What am I hoping you guys take away? You learned a little bit about the division of government that deals with permitting and air pollution on a regular basis. We have, despite small communities, even in the north and in other interior parts, we have pretty significant air quality issues. We don't have big city issues. We have littler city issues that also can be severe at times. We appreciate the role, or I appreciate the role that universities play in terms of the research, the studies we've done. Mike Brower has been involved in a number of studies in the Bulkley Valley, and those have been really important for me when I speak with municipal governments. Say, look, we've done some world-class research here. We know there's an issue, we know it's a problem, and we're studying it, and it's not just me that's studying it because you see me on the street all the time. It's other people who really know a lot and are leaders in the field. And if you ask me where we need to go, I think acute exposure to PM 2.5 is a big one for me. I see that was my case number one. Effects from low temperature wood burning organic stuff. I didn't really talk about that a lot, but wood stoves that don't burn properly emit more organic than inorganics, and those, from my understanding, have significant health issues. And then the synergistic part, like what I was just talking about. And yeah, we always value partnerships and studies. So if in the future you guys are doing work and you're thinking, I need to test this out in some place, well, come talk to me. We'll figure it out. Thank you.
Thanks, Ben. Questions from our audience here? And if you have a question, put up your hand and I'll bring you the microphone.
Ben, nice talk. Do you know who made the appeal to the Kitimat proposal?
Yes, I guess that microphone still isn't working.
I turned it off. I'll just.
Oh, okay.
I believe it was 8 different parties on 9 different grounds. So I may be wrong. It may be 6 parties on 9 grounds, but quite a few appellants and on quite a few grounds. And I don't know, or I may know more. I don't know how much more I can say, but yeah, it definitely is a sensitive thing right now, given that the smelter is currently under construction. Halfway kind of place, and every time I go to Kitimat, there's a new building, a new this, a new that, and so yeah, there's quite a lot of high stakes right now in Kitimat with that.
Thank you, Ben. It's nice to see the insides of the ministry. Often nice. So you said that the appeal is underway and should be the outcome should be announced in January. Surely that's going to be tremendously complicated by all the hysteria about LNG. How can they make those two decisions, or how can they make the decision in isolation of the LNG, which is still a wide open question?
I guess what I should say is, as the impact assessor and not the statutory decision maker, it's a tough thing for me to say on how someone else would make a decision. There's a lot of things to consider. When the permitting process had started in 2011, LNG wasn't a word in everyday vocabulary, and so that's why when you look at if you were to dig into the modeling study, which you can do, they didn't consider other emitters. There just weren't any at the time, and so yeah, now that it is, I'm really unsure of how that will work together. But yes, it's there's a lot going on in Kitimat.
Right. Sounds like major challenges for the decision makers. All right. Other questions?
Dennis from the internet.
Thanks for a very interesting talk, Ben, and for taking us on a virtual tour to places that probably not many of us get to fly over to see. My question refers to a couple of graphs that you showed with data of there were boxes and circles of neighborhoods, regions where there were some respiratory events. And it made me want to ask the question of whether or not there are any data, any information on hospital admissions or medical attention incidents as a result of the early morning high levels of emissions. It reminded me of Dr. Catherine Elliott's study. Dr. Elliott's with the BCCDC that looked at hospital emissions, and I think it was medication use with the forest fires in Kelowna. Yeah, thanks.
Yeah, I was supposed to mention that study, and then I forgot to because I was running late. But if you're referring to Kitimat, then what that study found was that in Kitimat, per 10 microgram increase in PM 2.5, there was a very high level of salbutamol. That's the right name? Dose. It's like higher than anywhere else in the whole province, actually, though the error bars are quite wide. So yeah, that's one of the two not forest fire affected communities where PM increases were heavily associated with that dispensation of that drug. So which is what goes into asthma or puffers, right? And I see heads nodding, which means I did it good. Okay. But yeah, so the early morning fumigation was from a different example, was from Burns Lake. So I'm not totally sure on exactly what your question is, though I know in Kitimat I have observed lots of fumigation. I mean, essentially what we know is that there's something going on in the community. However, when we stick instruments out to measure, we get low concentrations in the community where people live. So, and that's good. Kitimat normally vies for bottom of the list of on the ranking of communities based whether you use PM 2.5 as your metric or sulfur dioxide as your metric. So that's pretty a nice indication that if you had industrial facilities of that size located upwind of a community, directly upwind, you'd have the spectrum of issues would be way different.
Right. Yes.
Well, thanks a lot, Ben. It's really interesting stuff. Just maybe food for thought in regards to places like Kitimat that are actually relatively clean. I mean, there is sort of a phenomenon that's, I guess, hard to understand, but has been seen repeatedly in that the response of populations actually is more intense the lower the concentration, which you also have sort of analogies with smoking, for example. If you quit from 3 packs to 2 packs, you actually don't benefit from that. But if you quit completely from half a pack to no smoking, you actually get a big benefit. And there seems to be that kind of thing happening with air pollution as well. So that may explain some of what you're seeing in some of these communities like Kitimat, that it actually is clean, but it's that first bump up into sort of polluted conditions where you seem to get some pretty big impacts. So, and I do have a question. In that risk assessment, I know you didn't do it, but given a community like Kitimat where actually so many people actually work in industrial settings, do they consider occupational exposures of the population as well? So people are actually getting exposed at work and then the rest of the time.
So the first thing I'll say is if someone is really interested in knowing the more details associated with that one study, that's very well explained in the sulfur dioxide technical assessment report that was given to the ministry as part of the permit application. So if I try to paraphrase and don't get it right and you read it, it's different somewhere else, then that somewhere else is the right way. But I think they didn't consider that so many people work in the smelter or right around the smelter. The way they did that was by putting the service center, which is area A, which is where almost nobody lives. They included that, and they included exercise taking place there, maybe as a surrogate. But they didn't, and they have. From my understanding of the operation, the smelter operation, there's a health, safety, environment part of the smelter where they do look at they monitor individual exposure, etc. It's only just within the last few years that people working on the pod lines have been wearing wet respirators and to go in there. So yeah, they do take a lot of their employees' exposure to bear when they're there, but I don't know if the health study took that in mind and said, well, they're already exposed for 8-hour shift, and then they go back, and then they went and exercised, and is that, yeah, I don't think that's how it worked.
Thanks, Ben. Just, I got a comment. I was in Kitimat ages ago and looked at there were 6 different plot lines there. I think probably still are. And going back 30 years, the conditions in the plot lines were quite different from line 1 to the other lines. And going back further than that, the smoke in the plot lines was such that visibility was usually around 100 meters, was as far as you could see. And people did sampling of that, and it was a lot of PAHs in that smoke that came off the plots. So the air in there was not healthy at all, to put it politely. And yeah, that's sort of part of the history of Kitimat. People that have worked in the smelter for a long time have, and not just in the plot lines, other departments too. There was some pretty severe air pollution for people there for the 40 hours a week or whatever they worked. But yeah, and I suppose people coming out of the smelter going into the community would say the community air was perfectly clean. It's all what you're used to in a lot of ways. Yeah, Jing, you got a question?
We got an online question here. Jennifer asked, is there any idea on how to educate the public on how to interpret the new data taken with the new, more sensitive equipment? Yeah, she also said she asked this because the people will interpret the new data will be viewed as a real increase in PM.
Thanks, Jennifer. We being Environmental Protection Division have been looking into the best way of communicating the apparent change that will happen when we totally switch over instruments from those older ones to the newer ones that do a better job of emulating the reference method. It's called having equivalency status, and there's one brochure that's on the Ministry of Environment's air quality website, bcairquality.ca, where we try to start getting this information across. I don't know if there's a total media blitz that's going to happen. Some places, like everywhere in Vancouver Island, has already transitioned. And so yeah, I don't totally know if there's a large thing planned, or if you look at the BC Lung State of the Air report, they do have a section on the newer instruments. In I think the most recent one, and they've separated out the communities that measure with the older technology and the new technology. Smithers is the only one that has both, because we insisted that we keep it for a little while longer so that we have a really good understanding of the relationship. And but soon the older instruments will just break. They're not made anymore, and we'll be forced to just start working with the new ones only, and that's a good thing, I think. So. But I don't know if we have a giant communications strategy planned.
So that was a really interesting question, and well, I don't want to answer for you, Ben, but I suspect that there won't really be a need for an education program, because you'll only notice this thing if you're looking statistically, which very few of the population do. They may be looking at everyday values, they won't notice it, but you will notice it statistically. So then the question to you, Ben, is, are you going to adjust upward the older measurements to bring them in line with the TOM so that there doesn't appear to be a false step change in air quality?
We've talked about that too amongst the meteorologists. There's 7 regional meteorologists, and there's 2 meteorologists in Victoria, and then other air quality staff in Victoria, and we all support each other. And in fact, as a small aside, sometimes people in Victoria call themselves the Skeena subregion, because I always had so many questions. This is kind of related to some of the ones that we've asked, and personally I think that it's not a bad thing to when you're putting it into perspective at a community town hall meeting, for example, saying, yeah, no, it's not this giant spike that happened at the end of 2013, and so we didn't get worse all of a sudden from one year to the next. So this is what it used to be relative to what we know from the current co-located monitors that we have. I think readjusting is a good idea for the perspective of outreach and education, though I think the ministry is not going to plan on going back and tweaking all of the data, because we don't have I suspect that the relationship between the old instruments and the new instruments will vary by region. Like in Vancouver, there's probably not as much of a difference as there is in Smithers because of the way the TOMs worked. They did worse when it was really cold. And sometimes we know that concentrations were 200 or 100 times. Sometimes if you look at hourly values, they're 3 times as high as from a Sharp to a TOM. But so yeah, I think that we would really need a lot of data to go and readjust everything.
So just let me add to that, there's an interesting precedent for this. And that is in global sea surface temperature measurements. In 1946, the responsibility went from the British ships to the American ships. And the British ships measured sea surface temperature by tossing a bucket, and the American ships measured it by water in the intake, and the intake water was always warmer than the bucket's water. And so in order to do global warming studies, they've actually had to permanently adjust the record. And you've got to leave a flag with every adjusted figure.
Just a comment on the LNG story, as I've been understanding it so far, is that the cost of energy to run the compressors to compress natural gas into a liquid is very different if you buy energy from BC Hydro or if you burn your own natural gas to generate the power to do that. And there was some comment a year or so ago that the proposed LNG plant for Kitimat was going to be allowed to burn natural gas in order to make their costs lower. And therefore, if they do that, obviously there'd be a lot more emissions of SO2 and NO2 than if they buy power from BC Hydro or Elcan or whomever. So that will be another sort of interesting part of the debate that unfolds over the next year, 2 or 3, whatever it is, on LNG. Something to watch for.
Can I add a comment to that? I don't know how this. So the Tides Canada has just issued last week, I think, a very interesting study in which they says, okay, the Premier claims it's going to be the cleanest LNG on the planet. So what is presently the cleanest LNG on the planet? And there's a Norwegian plant and an Australian plant. So they took the emissions from those 2 plants and then did an analysis of what would have to happen in Kitimat with the proposed LNG capacity if they were to be as clean as those 2 plants. And it's absolutely clear that they cannot burn natural gas in the Kitimat Valley if they want to be as clean as those plants. They will have to use hydro.
Interesting, yes. Well, so as I said, it'll be interesting to hear how the economics and all the other factors work out in that one. We're past our usual time for winding up the seminar, so I'd like to thank Ben for a very thought-provoking and informative presentation.